Okay. All right, we are now recording. So you have worked the O2 number 3. In this particular problem, we had to think about the relationship between velocity and position, acceleration, total distance traveled, and how to find some of these different things. I will put, well, let's see. Put the scoring guide up first or not. Well, let's see. What do we get for the acceleration of the object at time t equals 4, part A? Negative 0.524. There you go.
How many points is that right?
1 point earned.
Just one for part A?
Yep. Now, in your response there, you need to make sure and communicate something. You're asked to calculate the acceleration at 4. If you just write the answer with no connection to anything down, it won't score. All right? You need to show the calculus you did. So how did you find the acceleration? Of velocity, right? Took the derivative of velocity, then state that. Tell them what you did. Write something to the effect of the acceleration at 4 equals v prime at 4, and then yes, you can just do it in your calculator and get your negative 0.524. You need to communicate what it was that you did to get that answer. Very important part of the puzzle. All right, cool. Part B. Now, you gotta be careful with these. If you read the first page, like I asked you to, you should have been able to get this. Consider the following two statements. Statement 1, from time 3 to 4.5, the velocity of the object is decreasing. So what do I want to analyze if velocity is decreasing, Mr. Larson?
The acceleration. I'm not focused on the slope of the velocity, right?
Yes, I want if velocity is decreasing, then its slope, which as you said is acceleration, should be negative on that interval. All right, so how did you analyze that?
I took the derivative of the velocity and then I found the critical number at, let's see, what was it, 3? No, it was at 4.5. And so I took it from 3 to 4.5 and it was all negative. So I knew that it was.
So you knew that what?
The slope. Let's see, the slope of v of t is decreasing from
Now you're phrasing. You said the slope of v of t is decreasing. The question asked is the velocity of the object decreasing.
So do I just say?
So you want to say velocity was decreasing. Slope of velocity is acceleration. You said acceleration is decreasing. So basically take their question, their prompt, and turn around and make a statement.
So just say statement 1 is true because the velocity is decreasing from 3 to 5?
Well, but now be careful. In a sense, we're just turning their question around and just restating it. You said statement 1 is true because velocity is decreasing. That's what we're trying to prove. Velocity is decreasing because you found what?
The acceleration.
Is
It's negative.
the acceleration is negative. So you want to say something to the effect of the acceleration at time t is the derivative of velocity at time t, which either if you, well, this part we want to show by hand. What was the derivative, Mr. Larson?
Let's see, it was cosine of pi over 3t times pi over 3.
Okay, so pi over 3 times the cosine of pi over 3t. All right, and that is negative. That would suffice for you to say, yes, statement 1 is true.
So you wouldn't even have to write out words.
Well,
Could you write like a of 4 is less than 0? Could you write that?
well, you can say statement 1 is true. Since acceleration for all time t on that given interval is less than 0. Yes, friend?
Would it be alright if I said because it's slope for that interval is negative, so the velocity is decreasing on that interval?
Because the slope for that interval is negative. Velocity is decreasing on that interval. The slope of what?
The slope of velocity.
Say that, and you got it. If you say slope of velocity is negative, then you're good. If you just say slope is decreasing, you haven't said if you're talking about slope of position, velocity, or acceleration. Be specific. Yes, sir.
I took values of V of 3 and I took values of V of 4 and those and it shows that V of 3 was greater than V of 4, equal 4.5. Does that show that's decreasing?
For two specific spots, yes. But is it decreasing on the entire interval? You've done a local argument. You said at two spots, 3 and 4, the acceleration was negative. You've got to make some statement like global argument. For all t's, the acceleration is negative. Now, they had already specified the interval, so I didn't really have to say on the interval 3 to 4.5. That was already kind of given in that statement. Yes, ma'am?
Since we had to take the derivative of velocity in part A, can we refer back to part A in our statement?
In part A, did you write that connection down?
I didn't put that A of t equals v prime of t, but I worked out v prime of t. Like I have the v prime of t
Okay,
on
so
the-
you've got that.
Yeah.
Okay, and then in part B, what did you say that you're referring to?
I said the velocity is decreasing because its value at 4 is negative because I just put in a value to test, and its acceleration is negative. And then let's see if I have part A.
If you haven't said that you know acceleration is derivative of velocity somewhere, that needs to be added to it.
So I just need to show that somewhere.
Yeah. And now also, it sounds to me like, Georgia, you're using a local argument. You've done one test number at 4. And you said since derivative is negative at 4, therefore I'm decreasing it. But that's the local argument. You've told me one spot. The question is on the entire interval 3 to 4.5. Yes, we do test a number to convince ourselves of it, but then we turn around and make the global statement. This says, you said A of 4 is less than 0. What you want to say is A of any time t is less than 0 on that interval. So it's just a matter of doing your number to test it and then putting in the global argument to communicate it.
Okay.
Now, statement 2 says on that same interval, the speed of the object is increasing. This is a concept we haven't discussed a whole lot. Maybe any, I'm not sure. On that first page, it has a discussion about speed, and speed increasing versus speed decreasing. And basically, you look at the sign of the velocity and the sign of the acceleration. If they're the same sign, then they're kind of working together and speed is increasing. If they're opposite signs, then one's working opposite the other and they're decreasing. You think of it that way. Now, if we model this, whether velocity is positive or negative kind of really doesn't matter. Let's see. If I'm here, well, okay, here's some cameras getting me. If I'm here and I start walking that way, what kind of velocities do I have?
Increasing.
No, not increasing velocities, but just positive velocities. So I'm moving to the right, I got positive velocities. Now, if speed is increasing, then I'm going to start walking faster, right? So what would you say about acceleration? Is it positive or negative?
Positive.
Yeah, I'm accelerating. My velocities are increasing, so its derivative acceleration is getting more. Okay, now, if I started here and I start walking really fast, so, I'm sorry, velocity was positive and acceleration was positive, right? So they had the same sign, so I was indeed, speed was increasing. Now, flip that around. If I take off from here and I'm going really fast, like a sprinter coming out of the blocks, I'm barreling out of here. But then I start slowing down a little bit. Velocities are positive or negative?
Positive.
Positive, but was I accelerating or decelerating?
Decelerating.
So acceleration was
Negative.
negative. So they were working in opposite directions, right? So was speed increasing or speed decreasing?
Decreasing.
So that's the way to talk about it, is speed is increasing or decreasing. If the sign of velocity and acceleration are the same, whether they're both positive or both negative, then speed is increasing. If they're opposite each other, then one is slowing the other one down, you can think of it as speed is decreasing. So what did you find on part B? On that interval, we've already said velocity, or, no, we didn't even talk about what velocity was, did we? We know acceleration is negative. What was velocity on that interval? On the interval, whoops, 3 to 4.5, right? V of t was what? Positive or negative? It was negative? Okay. All right. And now we can say statement 2 is it true or false?
True.
Yeah. Why? Yeah. Is true since both A of t and V of t are less than 0. And that's your justification. JT, did you communicate that?
Yes, sir.
Very good. Very good. That was a 3-pointer. Part B was.
What are the 3 points?
Pardon me?
Like, what are they all for? So 3
9.
points.
Is it, okay,
What
3
is
points. I
each
said,
point?
gotcha.
Yeah.
The fact that you got the statement 1 correct, that velocity was decreasing and you gave a reason for it, that's 1 point. The fact that you got statement 2 correct, that the speed is increasing, that was worth a 2nd point, and that you gave a reason for statement 2 was the 3rd point.
Okay. So like if I knew it, but I couldn't really get it into words, then I get 2. Like, cause I said statement 1 is true, and then I said statement 2 is false. I mean, I say they're both true, sorry.
But you gave no reason.
I mean, I gave a reason, but like not, I don't know if they give me full credit for it.
Yeah, okay, if you just say statement 1 is true and statement 2 is true, you're not gonna get any points.
Yeah, I said
It's gotta be
because,
statement, the answer with a reason.
okay, so what's the 3rd point?
Well, okay.
Awesome.
Is it my cookie?
You got the 1st point for the number 1 being correct with a reason.
Oh.
If you just say it's true, you don't get anything.
So like if I
If you
said.
say it's true and you give a valid reason, you're gonna get that point.
If I said because the slope of the velocity on this interval is negative, therefore decreasing. Did I get that? Okay.
But that is true, the slope of velocity is the acceleration.
And then the 2nd one is the one I couldn't justify that well, so I get.
Then you
2.
got your 2nd
Okay.
point. Right. Okay.
I love this song.
Where are we getting music from?
Janitor.
The janitor's jamming out to some Caleb.
Alright, part C, total distance traveled. What does Mr. JT have back there for total distance traveled? Got him jammed in the corner.
Distance was 1.432.
Total distance was how much?
1.432.
Disagree.
That's D. Part C.
Oh, never mind, wrong one.
So part C?
Part C?
Yes, sir. Total distance traveled by the object over the interval 0 to 4.
I didn't get it.
Didn't get it, okay?
Oh God,
Mr.
that's
Hunt?
probably.
2.387.
2.387, what did you write on your paper, sir? 2.387 is correct.
I got the integral from 0 to 4, the absolute value of sine of pi over 3t dt.
Okay? That will work. Now, you could, there's different ways to get in this guy. You can earn your points a number of different ways here. Let me erase this other stuff. Where's my dirty old rag? Here we go. Now, it is a calculator active question. If you can get this guy by hand, it's a lot more trouble, certainly a lot more time. We know that total distance traveled is the definite integral of the absolute value of velocity. Then, because they had already told us in the original prompt the velocity function, and they defined it as being v of t, you can just write absolute value of v of t right there. You don't have to rewrite out the sign of pi over 3t and all that good stuff. It's not wrong if you do it, but you know, maybe you accidentally forget the pi part or something, you know. So integral, so this right here earned their full credit. All right. That was a 3-pointer.
I don't really get how they did it with the absolute value, because I thought I did it right.
You don't get the absolute value part?
Like, I don't get how they took the integral of the absolute value.
Oh, it's just in the calculator.
They just did it in the calculator?
Yeah.
Oh, okay.
Yeah.
Yeah.
That's all you know, when you go in your Y1 screen, just hit math, right arrow to the next choice, and choice number 1. So hit math, and then right arrow, the very first choice is absolute value, so ABS. And then put ABS of, and then put in your sign function.
I forgot that we could use our calculator sign when we did it all.
I know, that's what I did.
Alright,
I
so
didn't
let's
count it all either.
keep that in mind, obviously. Now, this was a 3-pointer for this part C. You got 1 point for limits of integration on an integral of v of t or absolute value of t. Alright, so limits of integration, you got to use the absolute value in here, and a 3rd point for the right answer. Now, by doing all this other stuff, you have to think this object was moving one direction and it turned and changed a different direction if you did a full big blown analysis. By doing the absolute value of v, you don't have to worry about that. Now we saw a moment ago that from 3 to 4.5 my velocity was all negative, right? So my object was moving all left. But this integral is from 0 to 4. So I must have been moving right and then turned around and went left. So the total distance traveled would be all the movement right plus all the movement left, which will require 2 separate integrals because I got essentially 2 separate functions.
You
And-
get first point, what is the first point for? Just putting the
Limits
right,
of integration
the right limits?
on an integral that involved velocity.
Okay.
If you
Like
if you
just showing
integrated
that.
acceleration or something, wouldn't matter.
Just
Yeah.
like if you put like integral of, you know, b to a, I mean,
0 to 4.
0 to 4, and then in absolute value v of t dt, you get a point. Okay.
And if you calculate the correct answer, you get all 3 points.
I didn't do that.
Well, like I say, let the calculator do it for you.
Yeah, I just forgot we could use it.
All right, D.
I'll forget that.
What is the position of the object at time t equals 4? And then again, this requires more than likely the use of something like this, or you have to use your initial value. Now, we know that when you integrate velocity, you get position, right? So, if I want to find, what do I want to find here? The position at 4? And I was told the position is 0, right? I was told the position at 0 was 2. Okay. Keep this in mind. If you're given an initial position, whether it's at time 0 or time anything, that's a known quantity. You're either going to use this. Let me, JT?
Yeah.
Hunter?
Yeah.
If you're given this, you're either going to use this to find your plus c, to get your position function that you can then calculate the position at any time t, or you're going to use it for a fundamental theorem of calculus approach. Meaning that if I integrate velocity, we know we're going to get position. And this is motion along the x-axis, so it's going to be the x-coordinate at some time t. If I integrate a definite integral, we've talked about this a number of times now, I'll go ahead and use it. If I integrate it from 0 to 2, then this will be evaluated from 0 to 2. I'm sorry, 0 to 4, right? And this integral from 0 to 4 of v of t dt is going to be x of 4 minus x of 0. X of 4 is what I want. I can add the x of 0 that I know back over there. To reinforce another topic, when I do so, it is very, very nice to be able to think of this in the following way. My initial position was 2. Plus, what does the integral of velocity calculate for me? What is it now? Displacement. Yeah, not total distance traveled. Integral of absolute value of velocity does total distance traveled. But if I integrate just velocity, I get displacement. So basically, this is saying it's where I started plus the difference between where I started and where I ended. So if this distance right here is like 7, then it's going to say I started at 2 and I went 7 and now I'm at 9. And I'll have my position at time 4. This we can calculate on our calculator. Right? So we're going to get, well, I don't even know, I guess apparently, we know x of 0 is 2. When you integrate this on your calculator, just the sign, not the absolute value of, you're going to apparently get 1.432. And then when you add those together, we've got the position at time 4. I think that's by far the most convenient and time-saving way to do it. Otherwise, we do have to integrate by hand. We have to calculate our plus c,
That's what I was trying to do.
and then sub in 4 to find the position at that time t. That's doable. You know, does anybody need me to work through that portion of it? Okay, it's just going to involve a integration with u substitution. Is it sine of pi over 3t? Yeah, that's what it's going to be. I'd be happy to do it if need be. Apparently, when you integrate, that's your plus c. 3 over pi plus 2. And then just evaluate that at 4. Yes, sir, Mr. Larson.
Can you send me again where you got the 2 from? Like 2?
This right here?
No, at the bottom.
There. Well, from there.
Oh.
That's my x of 0. And the x of 0 is 2. That's my initial position. So the position at the end is going to be the position at the beginning plus the displacement. If you want to think of it that way, fantastic. Otherwise, just think, oh, if I want to find some function at some number, then I can get that by integrating the derivative function on an interval that has the value I want as one limit of integration and the value I know at the other limit of integration. What do you got, JT?
In that third step, why is it subtracted?
Here?
Yeah, like x.
Well, we do fundamental thermocalculus.
Yeah.
If you've got the integrated function evaluated from 0 to 4, you sub in upper minus lower.
But then in the next step, it's positive.
I added this to the other side of the equation.
Oh. Okay, that all makes sense.
There you go.
Okay.
There you go. It's the little things.
I thought that was
All right. Yeah, it's just that simple.
That's one of the hardest ones to get.
All right. Now then, let's move on. I don't want to. Oh goodness, where are we? Particle motion. Okay. Here's what you're going to do. We've just done. Now, I tell you what. Turn with me real quick. I'm going to just highlight a couple things for you. To the second page. That great big list of formulas we had. Let me pull the screen down. Maybe it'll show up a bit better for everybody in the camera too. Now, they put together everything you need to know about motion along the x-axis. There we go. Nice little thing. All right, and it's stuff we know. Of course, we're talking about initially. That's time 0. You know, the object is going to be at rest or not moving when the velocity is 0. Moving right when I got positive or up. Moving left or down when velocity is negative. Here I wanted to make sure and point this out. This is a biggie. if I want to find the average velocity on some interval, I've got two options. I can find the average value of the velocity function, which is all this is. That will give me the average velocity. Or I can simply do this calculation right here, which is when I do work this guy out, this is what it ends up being. But I can remember that average velocity on an interval is change in position over change in time. Feet per second. Velocity. The total change in distance, where I was at the end minus where I was at the beginning, over the total change in time. That'll calculate, this is the right-hand side of the mean value theorem. That's the slope of my secant line, the average rate of change. So I can calculate average velocity one of two different ways. Depends on what's given to me. I want to make sure and put that up to you. Instantaneous velocity, that's just derivative. Okay. Speed is absolute value of velocity. Again, speed is increasing if both velocity and acceleration have the same signs. Speed is decreasing if they have different. And we've talked about total distance traveled. And they call it net distance traveled, but we've been referred to it as displacement. Yes, sir.
I know you already went over the speed, but can you kind of clarify a little bit more?
I'll try.
Yeah.
Speed is what we call a scalar quantity. Velocity is a vector quantity. Vectors have both magnitude, how big it is, I'm going 40 miles an hour, and direction, which way. So the sign, positive versus negative, matters for velocity. If I say I'm going positive 40 miles an hour, it means I'm going that way 40 miles an hour. If I say I'm going negative 40 miles an hour, I'm going that way 40 miles an hour. If I say my speed is 40 miles an hour, that's called a scalar quantity. It has no direction, just magnitude only. So I'm going 40 miles an hour, you don't know which way. Am I in drive going forward, or am I in reverse going backwards? You don't know. But speed is absolute value of velocity. There's a couple of ways we can think of speed, and now they've referenced it in this sheet here. I'll try and clarify just a little bit. They say that speed is the directed distance from the t-axis. You guys remember seeing that when you read through it? It's on that first page. All right, yeah, that's why I kind of expected that. Nicole said I saw it, but I didn't know what it meant. Totally
Yeah.
expected that. Now, what they mean by that, speed is the direct, how'd they say it?
Speed is the non-directed distance.
Okay, non-directed, I'm sorry, I used the wrong word. Non-directed distance from the t-axis. So here we go. If I've got a graph of velocity, here's velocity. And I believe, if I remember seeing Keegan's graph right, on this last problem, my velocity curve was essentially some sine function that did something like that, right? So there's my velocity function. Now, at any time t, the sign of the velocity tells me which way I'm going, right? So let's say here is at t equals 1. And this is velocity. And this is motion along the x-axis. Which way is my particle going at time 1? Left or right? Here's time 1.
Left.
My velocity is negative, isn't it? So I'm moving left. All right. At time 2, what's my particle doing?
Zero.
It's instantaneously still. It's kind of like when I throw the cap up, just for an instant, it's perfectly still right there at that peak. Just for an instant. It doesn't have positive velocity, doesn't have negative velocity. It's just still. At 3, which way is my particle going? Right. Now, it is going right, or rat, as somebody said. Right? At 2, describe what's going on with the particle.
Stop.
It is stopped.
It's changing direction,
It's changing direction. From which way to which way, Matthew?
left to right.
Yeah. My particle is changing from a negative velocity, thus moving left, to a positive velocity, moving right. This is velocity. Now, if I said how fast am I going, I'd need a y scale, wouldn't I? Let's say this is 20 feet per second. So let's say, this being a sine curve is symmetric. It's negative 20 feet per second. So I can say at 3 seconds, my particle is moving to the right at a rate of 20 feet per second. I can say at 1 second, my particle is moving left at a rate of 20 feet per second. The sign tells me the direction. The speed, here we go. This was a positive amount. This one was a negative amount. It said speed is the non-directed distance from the t-axis. So the speed at 3 is 20 feet per second. The speed at 1 is 20 feet per second. The direction doesn't matter to me for speed. That's the non-directed distance. It's the y-coordinate there. Also, think of it this way. That's the velocity curve. Speed is absolute value of velocity, right?
Isn't a speed curve just like that?
Yes. Because absolute value takes everything negative and turns it positive. So velocity, the speed curve is going to be this. It's going to go up here and come down, and then instead of going down, it's going to turn right back up and go up again. And then it's going to stay positive because absolute value keeps positive as positive. And then absolute value is going to take all that negative and turn it positive yet again. So in red, I've got the speed curve. And at any time t, speed's always positive because it's the absolute value of velocity. Right? Now, I want us to flip over. I keep on setting stuff down. Ah, here it is. And let's look through some multiple choice because I ought to go a little quicker. So let's flip on through. We are going to come back and work the 06 number 4, but let's go through a few multiple choice. Take a few moments. The 1 through 6 are no calculator allowed. Let's take 6 minutes and crank through those. So 1 through 6 multiple choice. Timer is going now. Go, we're working 1 through 6 multiple choice. Yes.
What page is this on?
Page 9.
Uh-huh. Okay.
kicking her.
Just like that problem we told us about, we walked through. Where you have to add the initials.
Well, you could do it that way. I found my plus C right there. Okay, we've definitely gone over our 6-minute mark. Alright. Number 1 and number 2 you should have gotten. Because we've done these in class recently. At least the AB guys have. We did these like 2 or 3 days ago. Alright, well, let's see. So, Hunter's a little nervous now. What'd you get for number 1, Hunter?
I got C.
C is correct, it is 6. At time 6, my velocity has changed from positive to negative, so my particle is moving from up to down. It's a bug. It's a bug particle. It's a bug change from going up to down. Okay? Number 2, total distance traveled by the bug is B. Indeed. Absolute value of velocity, we have to take that little portion under the x-axis and flip it up above the x-axis, and it's area under the curve.
So do you just guesstimate by looking at it?
No, we do the geometry.
Oh, okay.
Yeah, we can. It's all line segments, so we can simply add up the areas under the curve. I looked at this as being, of course, with absolute value of velocity, it takes everything negative and turns it positive. So I looked at it as adding up the area of this triangle, which is easy 1/2 base times height, plus the area of that rectangle, which is easy length times width, plus the area of this triangle, which is an easy 1/2 base times height, plus the area of that triangle. All adds up to be, I think it was 13. All right. Number 3 ends up, Samantha says, C is correct. All right. I hope that one was relatively straightforward in that, whoops, gotta erase the board again. And I've got my answers up here for the next couple. But yeah, for what values the particle, velocity 0, we take the derivative, set it equals 0 and solve. That ought to be pretty straightforward. For number 4, I got D.